solving simultaneous linear equations. So what we're doing here is we're looking at two different lines or two rules or equations for different lines, and we're going to find a meeting point, a point at which they meet. So what we do with these ones, one like this is fairly straightforward because they're both in our y-intercept, y-intercept and gradient form. Now what we need to do is obviously plot the points like we've done previously. So for the first one, we're going to do these graphically, then we're going to look at some where we're going to solve them with substitution and elimination, but for now it's just graphically. So what we do first of all is find the point for the first one. So positive 2 is our y-intercept. So we're going to find a point, we find that point which is here. Okay, just grab a pen and plot that point. Then obviously the 3x is the same as 3 over 1 as our gradient, so 3 being the y step would bring us to 5, and 1 for the x step. So they're the 2 points that we plot for that. What we then do, grab our line that I've already done for us, put that one in, so plot that in there, sit that one in there. So that one there would be our y is equal to 3x plus 2. So then the next point that we're going to have a look at here is our y is equal to x take 2. So we're going to make this one red so we can tell the difference. So obviously negative 2 would be our y-intercept, so we'll chuck that one in there. X is obviously 1x, so we're going to go 1 up and 1 across to the right, so 1 up and 1 positive. So the other point would be here. Now we've got a line for this one. Grab that line, might just make it red for us so that it stands out. Got that done. Now we bring that one in, put it through the y-intercept through our point, and see that they both do have a meeting point, so it does mean that they do have a solution. What we then do is go to the part here, we'll write what the rule for that line is, x take 2. Now this point here, now I might do it in blue, so it's this point here where they both cross over, they intersect, so it's an intersection point. So our intersection for these two lines or these two equations would be, it's negative 2 on x, so negative 2, the y-axis is negative 4, and that's how we would solve these graphically. Okay, so that's one example. Now another example we've got here, we're just looking at question 2, is one where we've got one, up the top one here is in the y-intercept and gradient form, so that one's nice and easy, we can plot that one with no problems. So if we were going to do that, you'd find, for example, you've got your negative 1 as your y-intercept, so if we say this is our negative 1 here, just label that one. And then you've got to go with your x, which is 1 up and 1 across, so that would give you, for some reason it's not meeting up with the, we'll go with just the lines here, so you've got negative 1 and 1, okay? So what you can do here, now we've already got these ones set up, so we can pop that one in there, that one being our y is equal to x take 1. Now, the bit that's different here is the 2x plus the 3y is equal to 12. What we need to do here, we need to get y by itself. Now, what we need to do with that, in that case, is to rearrange the equation. So the way we do that, what we would do is you've got 3y here, you've got 2x, we'll get the 2x on the other side. So we have 3y is equal to negative 2x plus the 12. Now the 12 is still there, and it's a positive 12. Now, we still need to get the y by itself here. So what we do is we divide that by 3, which will give us an answer of y. Because we've divided that by 3, we must also divide that side by 3. So the first part, this first term, will go together. So you have your negative 2x divided by 3, which we can't work out to an even number. So you do negative 2 over 3, x, plus 12 divided by 3, being 4, will give us a new rule for our line in the gradient intercept form. That is this one here. Okay, so that's the one we're going to graph now. So 4 we know is our y-intercept, so we'll come up, so you got your 1, 2, 3, and we'll say 4 here. Then we've got -2 over 3. So -2 being our y-step means we're going to come down 2 spots, so 1, 2. We're going to go out 3 spots, so 1, 2, 3 to here. Now, we can already see that that point that we've just plotted there is going to be our point of intersection. Okay, so just fix this one up a little bit. So it's a bit more through the point. We then write that the rule for that one being 2x plus 3y is equal to 12. We've got our point here, so we'll draw the little point in a little bit more detail there. Now we can work out that that is 1, 2, 2 on the y-axis. On the x we've got 1, 2, 3 on the x-axis, and that is your intercept. Point of intersection. So that's how we do one when we've got them in different forms.